I'm Tim Cook with Cook Saw Manufacturing. I'm here today to show you our HD32 thin-kerf sawmill and to show you what makes this mill the best mill that's on the market today in its class and size. Give you a little bit of background about me. Our company has been building, our family has been building sawmills for more than 25 years. I personally have been sharpening saw blades and tending to saw blades for more than 35 years myself. My dad was a saw filer, my granddad before him was a saw filer, and so we've got saw filing in our blood, we've got sawdust in our blood. But one thing we do is we like sawmills, we like saw blades, and so you might say that's what we know best. But this HD32 mill is built heavy, and that's what I'm going to show you about. You're going to see me talk about how heavy this mill is. When you compare this mill, now it's 32-inch wide in the throat. Our 36-inch mill is 36-inch wide in the throat, and the 36 mill is our biggest mill, but this 32 mill is built with the same framing. This frame is the same. Your framing up in the head is the same. It's got smaller diameter wheels. That's one of the things it has. The bearings in the drives are a little bit smaller, and you can see that our main frame of the sawmill is the same heavy frame. Our log turner loader and our log turner are the same, and I'll show you more about those when we get to them. When I look at a sawmill, I want to know, is it heavy built, is it stout, and is it adjustable? So the main heart of the sawmill is the blade. This is the main heart of the mill. And then when I look, well, what supports the blade? This is the most important part of how a sawmill is made. I have seen so many mills built that had a good frame, they had good log turners, good clamping system, and this part right here didn't work, and that made that entire mill a big, expensive piece of scrap iron. And that's what you don't want to do, is spend your money and have scrap iron. Now what we build is steel wheels. It takes two wheels. We got a drive side, we've got an idle side. The idle side has a bearing inside of the wheel. The drive side has a drive bearing assembly that supports that wheel with very much strength and accuracy. We grind the crown in this wheel. Crown is for tracking. You must have the right crown. We grind that crown into that wheel precisely just like we want it. So we support that wheel. These wheels have a vertical alignment adjustment. That means this away. That has nothing to do with tracking. Tracking has to do with this direction. And so we have that maintained as well. I'll show you that when we get on the back side. So we've got two wheels. We got a tensioning device on this side, and we've got a bandsaw blade. That is the heart of how this whole sawmill works. That is the heart of how any sawmill should work. So now we look and we've got guides. The guide's job is to support the blade to saw straight away. Straight away should be the least path of resistance. When this mill is adjusted right, when the blade is right, it will saw straight. You can enter the log as fast as it will saw the log, and it will not rise up and settle back down. It will not dip when it goes into the log. It will saw straight. If you've ever seen a mill that was sawing, that was rising and falling and cutting bad lumber, that's a bad mill, that's a bad setup. You're seeing problems. This mill won't do that. It will saw straight when this blade is maintained and when it's adjusted like it should be. Now, the next thing that is our roller guides. In our roller guides, we have a receiver in the back. It's got a square hole. We have a key stock like that goes inside of that square hole. It gives us the adjustment of up and down, side to side. We can precisely adjust that and lock it down. Then we have, in this area, we have a guide that's adjustable up and down that does not affect the tilt in any manner. And so we can get our down pressure on the blade. We expect to put a 1/4 inch of down pressure on the blade. That way our guides can control it. When we line these mills up, we actually tilt these wheels forward out of square just a little bit. That makes that blade angle down a little. When the down pressure comes on, it makes that blade go straight. Then we adjust these guides till that blade is straight away, and that blade will just zip through the wood. Some people ask, why do you tilt the wheels? I can just tell you from experience and years of testing these things that it works best. And when you set these mills up square, it won't saw straight. It wants to rise up. And I'm saying straight up and down would be square. So they're out of square just a little bit. A lot of these little things we've learned from the School of Hard Knocks, and we pass them on to our customers when we build a mill like this. The next thing we have is a dripper system. We have a filter, we have a on and off valve, and then we have a old-timey, I call it the old-timey oil dripper, sight drip. So you can see the drip form and it falls into the felt wiper. It wipes it on the blade. I like to put automatic transmission in with diesel fuel or mineral spirits, anything you want to put that has a solvent base, but the transmission fluid gives lubrication to this blade and it works very good. We have a movable guide over here that's hydraulically moved in and out. It's a very stout guide system and it holds well. Now when you see as this blade rotates, it cuts in this direction. When we come into the log, our log locks up on this side of the mill. We enter, this is the most stable guide. I call this the least stable guide, but this is the most stable guide because it's rigid, it has no movement. This one has a little bit of movement that allows it to slide in and out, so it's the least stable guide. Now I like to enter the log on the most stable. Now, when I come over here, and I'm showing you this so you can test the mill, I want to know if I can shake this head up and down, and I can't. That thing is rigid made. I can go to the other side and it's the same thing. If I come over here and I push up on this head, I can't move it at all. I want a stable mill. I'm entering the log on this stable guide. I'm receiving it over here as it exits the log with the guide that's movable. That is the most stable way to saw with a sawmill. You'll notice here we've got the rods that come up and down. We have a guide system that has brass bushings in there. It's greasable. You'll see the grease that's on there. And that's what guides this head up and down properly. It's lifted with 60 roller chain, which is a very strong chain. It can lift that head up and down with accuracy. This mill is very stable, cuts very accurate lumber. For anybody who's wanting to get into the business, it's not our highest production mill, but it is a mill that'll give you a lot of production every day. It will drive an 1.5 inch blade or an 1.5 inch blade on these wheels. On this side of the mill, I wanted to show you our drive bearing assembly. You're not going to be able to see it real well, but it'll pan in a little bit, and I'll describe it. We use tapered roller bearings. We use a heavy-duty shaft. It is mounted to a plate that we call a book. And if I open the book, it will let this wheel move this direction. And we have bolts that you can adjust to do that. That allows for your tracking. This bearing also has adjustment that you can get your tilt right. Of course, we set that right from the factory, but it allows you the option that later on, if you need to readjust it for any means, there is the adjustment there. Then I want to pan up to our head lifting system. We use a gear motor with a gearbox with a hydraulic motor, and that drives our chain system. And we get a smooth lifting up and down. It locks out, it holds steady. It doesn't vibrate down or leak down or anything of the sort. It does a really good job. We're really proud of how that works. If we pan down, you can see the 60 roller chain. You'll see this is on both sides of the mill. This is very important that we pull from the back side, pull from the front side. Now what that does is it gives stability to this head so there's no seesawing as it goes through the cut. We want this blade to go steady. I want it to be even. Each tooth is going to bite about 0.010 bite, and if each tooth is doing its job without any surges, then this blade is going to cut like it's supposed to do. That makes the mill look good. All right, I want to show you on this side of this HD32 our tensioning device. That is a very important part of maintaining your blade properly. We have a hinge point that is in the center of these two plates, if you'll notice. And what this allows is it to hinge, close and open like this. And so we have a rod that comes through here. We have a turn crank that we can back the tension off. And if I back it completely off, then you'll notice that this hinge plate collapses up. And if I pull out on it, that's the action that the crank does for it. So I'll crank it back out. And as I crank this out, we have a block that's threaded up inside of here, and then there's a spring in front of the block. So this is what I call a live spring tension, is what we have here. I bring this out to a measured point, and that's where I want to tension it, right there. Very easy to tension, very easy to maintain. Now on this mill, when I tension a blade up, I don't have to revisit this tension until that blade is dull. I tension it one time and I saw with it till it's complete. Now there's mills out there that have hydraulic tensioners in here with no spring. I call that dead tension. A bandsaw blade has to expand and contract. Expand in the log, in the cut, and then contract as it comes back out. With this spring system, it will give and take. When it expands, it takes out and maintains tension. When it comes out of the log, it gives it back. Now, a hydraulic tensioner that has no spring has to jack that tension all the way out, and then it can saw. But then in just a little bit, the blade warms up and it starts relaxing. Then you have to go back up, retighten that tension some more with the hydraulics, and then you have to do that 2 or 3 times during the time you're sawing with that blade till dull. With this one, I tension up one time, maintains the whole time through. When it's dull, I stop, take it off, put another blade on and tension up. Now I want to show you, here is the tracking device. I explained on the other side, it's like a book. It opens and closes. We have 2 bolts here that will adjust that. Now when I open the book, that lets the blade run forward on the wheels. When I close the book, it brings the blade back. It's a very stout, it's very rigid and very easy to adjust, very easy and quick to set the tracking. Also here we have a magnetic scale, we call it. You can see how it'll pop off. I can pull it off from the top or the bottom. Both of those will adjust. I can adjust them up and down. I also have a metal pointer here. If you can look down, we have an adjustment on the rod that goes up and down, so we have some fine-tune adjusting there. This scale rides with the head. The pointer stays at eye level all the time. So we have the same trajectory of this needle on the scale at all times. So we get the exact same measurement when we're sight sawing with this mill. Some people have the opinion that sight sawing is not very accurate. We have a 2-speed hydraulic system that when we flip a switch, we go into slow speed, and our hydraulic motor moves at the rate of speed that we adjust on a hydraulic needle valve. So you can set that to whatever you need to fit your needs. And you can get a very accurate measurement. We have, on this scale for instance, we have the 1 inch on the left, 4/4, and then this one has 5/4 and 6/4. We have many other scales made up. We have cross tie scales where it'll start at 7, and as you start sawing and come closer to that 7-inch mark, you land directly on a 7. For instance, a cross tie is like a 7x9. Some of them are 6x8, 7x8. So you start at 6 to saw, you can start at 7 to saw, or start at 8, and the scale is worked out so all your 4/4 number lands on the number that you want, so you don't have to saw that shim. On this side of the mill again, you'll see the chains. We've got nice heavy duty rollers and we have a V-track on the top that's like a rooftop. It's self-cleaning, and it just sheds the trash away, the sawdust that's going to land on it, and as the wheels roll over it keeps it clean. And so this is a very heavy mill. There's none on the market that are heavier. When we set a mill up like this, it is a very good mill. It'll last you a lifetime. You can pass these to your grandkids, and your grandkids can build their houses with them. Now we're to the bed frame, or the loading and the turning, the clamping, what happens in the bed of the mill. I want to show you how heavy we build this. I keep stressing the word heavy, and I want you to remember that, because when you're comparing this mill to other mills in its class, you're going to find that nothing is built as heavy as this mill is. Nobody's building a mill like we're building. And with the technology that we have that things work smoothly together, there's just no comparison. But here is the log loader is the same loader that we put on the AC36, loading bigger logs than this mill will handle. So this loader will load anything you put at it that's small enough to fit within the frame that this can saw. And so when we lift the log, we're going to load it up here. We don't want this failing. We want it to lift a big log if that's what you're going to saw. In this section, we have the log turner. If you'll notice, we've got a 120 roller chain. We've got 1/2-inch plates on each side. Our bearings are made with steel blocks with bushings, oil impregnated bushings. They have greasable points. That log turner's indestructible. Now, if you use it long enough for several years, you can wear it out, but you can't destroy it. It is made where you can't destroy it. You compare this log turner to other log turners that are on the market, and you're going to find they look like tinker toys when compared to this log turner. This log turner can take a beating and keep on ticking. Our log clamps, they go up and down, and they do that together. They will clamp, and the one with the least amount of pressure will come across and clamp the log. Our squaring arms down in the bed, you'll see those come up. They are adjustable. We want them to be squared with the bunk, but they'll come up square. You can square the log against them. You can push with this log turner. They're heavy build as well. And if we can hold that log square, we're gonna saw it square. But these are the things that I'd like for you to really pay close attention to, and how well we've built them. And we'll fire this mill up in just a few minutes and saw with it and show you how well it handles the log and how easy it turns the log. Here are the controls to the mill. I'll start with our manual controls. Here's the log lift. Lift it up, the log goes up, put it down, the loader comes back down. There next is your squaring arms up, squaring arms down. Everything is ergonomically put together. Our log turner, when I push it to the left, the log turner goes down. Push it to the right, it comes up. When I push it forward, it turns going up. I pull it back, it turns going down. Now, it's not intended that it turn the log down, but sometimes you need to scoot the log or adjust the log a little bit. But it turns while going up. Then we have the front taper, goes up, then down. The back taper, up, then down. And then we have our log clamps. We call them the dog clamps in the sawmill industry. That is up, that's down. That swings it to the left, and this swings it to the right. Anybody that has any abilities can step in and run this mill in just a few minutes. Now I'll show you our hand control box. This box is movable. I can move around the log, move to the back, and have this with me. It's pretty simple. I've got a forward, and then I turn this off, and I've got reverse. My guide is in and out. My head is up, down. This is a power switch. This will turn all the power off to this box. I've got a fuse link, and this switch is fast and slow on the up and the down. So if I may be going down and I go from fast to slow, I don't have to let off the down. I just go to the slow, and it comes down, and it'll slowly crawl to the number I want. I turn it loose, hit forward, start sawing. So if you once you get used to this, it really works easily. We have a holder box for our control box that you can drop in here. This is the flow control for the forward speed. It does not control the reverse speed, it just controls the forward. So it's like a stick shift. You can set that. I'll wait for this helicopter to go over. I really like this flow control valve because it makes it real easy to adjust your speed while back in this area of the mill. One thing I didn't show was how this control bar can swing around and change positions. It has a position that it swings over and locks up for being portable, but once you set up, you can move this out. I like to move out to here, turn my log where I can see it, and then a lot of times I move back into this area to saw. I'm also here if I need to help that board left or right, just to stay in its track coming back. Our tongue is removable. This tongue has 2 pins up inside. Pop those pins out, pull it out, the tongue comes out. It's a very heavy built tongue. it's something you can put in the trunk of your car, in the back of your truck, and it makes it hard for somebody to take this mill and tow it or steal it or give you any problems with it. As we look down to this area, this is the drive motor, and this is the drive shaft that moves these chains that pulls our head forward and reverse. So this is what we call the driving end of the mill, where that drive shaft is. As we follow these control lines up and over, you'll see what we call the umbilical line. What you'll see is we have a pulley that rides a cable, and then we have a chain that is fastened to the hoses, and this chain can swivel in any direction that we need it to, and it can adjust any way that it needs to. It makes this umbilical line really work well. This is actually my favorite way to move these lines back and forth. There are other ways that we have on the AC36 that has this plastic carrier that goes back and forth, makes it look like a real fancy machine, but I actually like this better. But this is what we choose to do with this mill. It also keeps the expense of this mill down a little bit. As you can see there, you can cut a lot of lumber in a day's time if you're sawing with one of these mills. You can look at the uniformity of the wood. Look at how very little sawdust left on this log, or left on the lumber. Now that's not the whole point of sawing, but what that says is that blade is cutting properly, it's cutting straight, and that it just says there's a good function going on when the sawdust is grainy like grits. You can probably see here, I'm going to try to show it to you. There's a big knot right there. I've seen so many mills, when they hit those knots, they ride up over them or go down and go through them. And I've heard people say, well, the knot's got a different grain texture and all that. The blade doesn't know what kind of grain texture is there. All it knows is it's cutting straight to the least path of resistance. And there is a least path of resistance in a hard knot. And if it's adjusted so that it's straight through, the machine is set up right, it will saw straight through those knots, no problem whatsoever. And these knots in a southern yellow pine are very, very hard knots. And the white pine up in the Virginia areas is really hard, but it'll saw straight through them as well. But there you have it. This is what you can do with an HD 32 mill. You can saw more lumber than you can nail up in a day's time. It'll take you a long time to nail it all up.